Let's look at proposition number 36 of book 3 of Euclid's Elements. The proposition says we are given a circle and a point outside the circle, and we have two lines, one cutting across the circle and one touching the circle. So let's draw those two lines. Let's take the center first, and then let's draw the line passing through the center and the other touching the circle. Now, the other case is when it is not passing through the center. So we will look at it later. So we have two lines from a point outside the circle, one cutting the circle and the other touching the circle. Then the proposition says that AD by B and this point of intersection, that is C, AD by DC is equal to dB square. Now, the same thing would apply, AD by DC equal to dB square, even if this line is not passing through the center. So again, let's look at it one by one. First, let's take the case of it passing through the center. Now, let's join FB. Now, FB is touching the point of contact of BD, which is touching the circle. So that angle is going to be 90 degree. So since this is a right angle triangle, we can say FD square is equal to BD square plus BF square. And in book 2, one of the propositions says that if we have a line AC with F as the midpoint and AC has been extended to D, then AD by DC plus FC square is equal to FB square. But FC square, or rather FC is equal to FB. So we can replace FC square by FB square. So our expression becomes AD by DC plus FB square is equal to FD square. But we saw previously FD square is BD square plus BF square or FB square. So our expression becomes AD by DC plus FB square is equal to FB square plus BD square. So FB square appears on both left and right hand side of the equality. So we can subtract them out. So when we subtract them out, we are left with AD by DC is equal to BD square. So that was the first part. Now let's take the second case. Now in the second case, the line AD is not passing through the center. So again, we have to prove that AD by DC is equal to BD square. Now here we will have to do some constructions. Let's figure out the center. Let's join DE. Let's join EC. Let's draw a line perpendicular to AD from the center E. We know how to do that. So I will directly mark it. So this is 90 degree. And let's join EB. So now we have this line where AC is having a midpoint at F and it has been extended to D. So like before, we have AD by DC plus FC square is equal to FD square. So what we'll do is we will add FE square to both the sides of the equality. So we end up with AD by DC plus FC square plus FE square is equal to FD square plus FE square. Now remember, we have a right angle triangle here, DEF, and CEF is also right angle triangle. So we know FD square plus EF square is equal to DE square, and CF square plus EF square is equal to CE square. So in our equality, AD by DC plus FC square plus FE square, that FC square plus FE square can be substituted with CE square, is equal to FD square plus FE square, which can be replaced with CE square. So our equality becomes AD by DC plus CE square is equal to DE square. But CE is equal to BE because they are radii of the same circle. So we can substitute that into the equality. AD by DC plus BE square, instead of CE square, BE square is equal to DE square. But DE square is what? It is DB square plus BE square, because this is again a right angle. Why? Because the DB is touching the circle, and EB, if we extend it, is the diameter of this circle. So the diameter is touching the point of contact of the tangent. So this angle is 90 degrees. So this is a right angle triangle. So that's why we have DE square is equal to BD square plus BE square. So our expression becomes AD by DC plus BE square is equal to DB square plus BE square. Now BE square appears in both the sides of the equality, so we can subtract it out. And we are left with AD by DC is equal to DB square. So we have proved both the cases. That is proposition number 36 of book 3 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download, refer to it, and if you feel somebody else can benefit from it, please do share it. That's it for now. Bye.